our project. So first we have to create a folder. We'll call it starter file and open this folder in your VS Code. Come back here, click on this open, go back to desktop, and this is the folder we have created. Simply select this one and open. So I have opened the folder successfully, and now we have to simply clone the entire starter file which I have already provided to you. So to get the starter file, you can simply come back here in the browser and come back to the blockchain coder. There you will find all the resources, all the project we have built on our channel. So you can click here, go back to the source code section. There you will find all the project we have built on our channel. So we have more than 50 project related to Web3. So check all of the project we have built. So simply come back here and search for the project we have built. So this is the one we are building. Click on this get now, and you will come back to the section. You can get the final source code or you can get the starter file, and when you will get the final source code, you can simply watch the video in which I have explained how you can do the setup. So simply click on this get starter file. You will come back to the getup, and this is the entire structure I have given to all of you guys. All the instruction is already given that what are the packages and libraries we are utilizing. So simply copy the URL, and this is the repository we're going to clone it. So come back in the VS Code, open, make on the big screen, open up your terminal, and you have to simply type git clone, and you have to paste the URL, and you have to give this dot. So it's not going to create a separate folder inside this particular folder, and hit enter, and it's going to clone the entire repository. So you can see we have successfully cloned the entire repository and everything's looking great. Now we have to simply clear our terminal and simply close this one. Now we have to simply delete this one because we don't need this. Looks great. Now you can come back to the folder and file structure. So the very first folder we have in our application is the component. Inside that you will have all the components which we're going to code together. Like this is all the components you will find. Everything is provided, looks pretty good. So we are importing all of the components right up here, and we are exporting. So we have the loader. That's all you will find here. So there is nothing in here. Everything is empty. We're going to code everything. So this is the component. The second one we have is the context. Inside that we have this constant, and I have already given you this network configuration. All of this network configuration, you can literally deploy your contract to any network, but in this project I'm going to deploy to Ethereum test network, either this or this. In this I have the fund, so I'm going to use this particular network. So if you want to use any network, make sure to provide this exact configuration. As long as you provide this exact configuration, everything would be working fine. I will also cover everything that how you can configure this network in the MetaMask as well. So make sure to provide the relevant information, and when it's come to getting the RPC URL for the respective blockchain, make sure you use this particular website ankr.com, because they always provide the good RPC endpoint which will be very effective to getting the data very quickly. So this is all the network configuration we have here. Close this one. This is the general ABI which I have provided for ERC20 token. You can use it, or we're going to simply generate our own ABI when we'll deploy our contract of token. And here we're going to write all the context management. That's what we have. Here we have the two contract for ERC20 token and for our ICO contract. Then we have the pages. So we have 3. Here we're going to do the configuration for our wallet and the context management. Here we have the 404, and here we have our index page where we're going to write the entire code for our front end. Perfect. Then we have our public folder. Inside that we have the assets which you don't need to do any changes. If you want to do it, you can do that unless until you know how to do it. So you can see all of this we have. Close this one. Close this one, close this one. Perfect. Then we have this style. Inside that we have imported all the CSS file, and we have written all of these classes which you don't need to worry about it. This is the normal classes we have. Close this one. Then we have the utils. Inside that we're going to write a couple of utility function. Perfect. Here we have the get ignore. You don't need to worry about it. Come back to the package.json file. Here we are using all of these packages in our project. So everything is looking great. Here we have the readme file where I have provided you all of this instruction that what are the things you can utilize it, what are the things are there. So everything is looking great. Everything is looking great. Now open up your terminal, and this time we have to check our node version. So if I show you my node version, this is the latest one I'm using, and I will go with the latest one, but you can use the previous version as well, because in this project we are not using hard hat. So you can go with any version, but if it's create any problem, you can simply downgrade, and I will show you that what exactly you have to use. So this is the one which I'm using. If I show you my NPM version, I'm using the latest one, and I will go with that. Now what we have to do is we have to install all of these packages. We have to use it. So first, see, I have to simply clear our terminal, and we have to install. Simply type npm I, hit enter, and it's going to install all of the packages. You can see I'm getting this particular warning that this particular version is got depreciated, but we want to use the exact version. So don't make any changes. It's recommend you a couple of commands and telling you to run this to fix this, but we want to use the exact version. So just leave it as it is and install the packages. Once you will install, you will have this node modules. In that you will have all of these packages we have installed. So we are done with all of this installation. Everything is looking great. Now we're going to start working on our smart contract. So if we can come back here, and we have this two contract. So this is going to be our ERC20 token contract. We're going to use emix IDs package, and here we're going to write our entire smart contract for custom. So first we'll start with this, then we'll go to this, and after that we're going to simply write the utility. Then we're going to write our contracts here, the constants and the index, and after that we're going to simply deploy our contract. So let's start writing with our contract first. So come back here and let's writing our token ICO. Now we can start working on our smart contract. So first we have to build the interface. So we can call this interface ERC20, because here we are dealing with ERC20 token. So we have to build out all the functionality which we want to use in our ERC20 token. So let's write the very first function. It's gonna be called transfer. It's going to take a couple of arguments. So let's build the layout first. It's going to be external, and it's going to return our boolean value. After that we have to take another one. This will be called balance of. This particular function will allow us to check the balance, external view, and will return the UNT variable 256. Then we have to take the third one, and we're going to call this function allowance, external view, and it's going to return the UNT variable. Then we have to take the fourth one, and this will call approve, external, return, and it's going to return the boolean value whether the user is approved or not. Then we have to take another one. This will be called transfer from. It's going to take 3 arguments. So we'll call it external, returns, and it will return the boolean value. After that we have to take the regular function like symbol, and it's going to return a string. So we'll say string memory. After that we have to take the total supply, external view, return, and it's going to return a UNT variable. Then we have to take the final one, which is going to be the name. So it will be string. Perfect. So this is the entire interface we have for our ERC20 token. You can do the exact thing out of the contract, but I want to make everything controlled by the smart contract. So that's why I'm taking this internal interface. So we got our interface. Now we can simply take out all the inputs we're going to take and receive in this function. So let's start with the very first one. Let's formulate this one, and let's come back to the transfer one. So it's going to take 2 arguments. First is going to take the address. So in Solidity we have to give the data type, that what type of data type you want to receive in the function. So that's why I want to give address, because that's what I want to receive. So I'll call it recipient. This is going to be the key pair, and again I have to define the data type. So this time I'm going to take the UNT variable, and it's going to be the amount. So in Solidity, whenever you want to receive any data, you have to define the data type, and you can give the key pair. It's going to be the name of the variable. So this will be amount. Same thing I have to do with the balance. So it's going to take the address. We'll call it account. So you can pass the address of any account, and it's going to give you the balance of that particular token. Let's come back to the allowance. It will call address, honor, and it will take the address of the spender. It's going to return the amount which we have allowed to a third party address to spend the token on behalf of us. Then we have to check the approval status. So in that we have to simply pass the address of the spender, and we have to pass the amount. So we can check that whether that particular account is approved or not. Then we have this transfer from. In that we have to pass 3 arguments. First is going to be the address, the spender. The second one is going to be the recipient, and the third one is going to be the amount. Perfect. Now we can come back to the symbol. So it's not going to receive any argument. Just keep it as it is. Total supply is going to be as it is, and name is going to be as it is. So this is the entire interface and all the data we're going to receive in each one of this function. Looks pretty fine. Now we can start working on our actual smart contract. So we can come back here. I can call it contract, and you can literally call whatever you want to a smart contract. So the best strategy we follow in the industry, we try to give the name of the company and the project. So here we are dealing with the ICO token. Then we have to give the exact name. So we'll say token ICO. It's going to take couple of data. So first thing what we have to do is we have to define couple of state variable. So this one is going to be the honor. So when the contract will deploy, we have to assign the honor of the contract. The second one is going to be the address of the token. Then the third one is going to be the price of the token sell price. And here I'm getting some sort of warning. Okay, I have to remove this L and I have to give this. We got our 3 state variable, and I'm going to take one more state variable because I want to keep the track of number of tokens are getting sold. So that's what I'm going to keep track of it. So we'll say sold tokens. So these are the 4 state variable we have. Now I'm going to build the modifier. So what I'm going to do now, let's build the entire structure of the function we're going to have in our contract. So we're going to have modifier. It's going to be called only by the owner. So we're going to have a couple of functions within our contract which is going to control the restriction. So only owner can call those functions, not anyone else. That's why we are taking this modifier. We got it? Now we can simply come back here. Let's build the constructor. In that, we're going to simply update the address of the owner. Now let's start working on the functionality. So the very first function we're going to have in our contract is to update the address of the token. So we'll say update token and it's going to take input. So it will be, let's build the skeleton first. So this is the update token. The second one we're going to have is the update price, token sell price. The third one we're going to have called multiply, because in that we have to simply pass the 2 number and it's going to give us the value. So that's the internal function we have taken. Now we have to deal with the buy function. So let's call this buy token. Now we have to build another one called get token details. So this is the function which allows us to get all the information about the token which we are selling through this ICO. Then we can come back here. Let's call this function transfer owner. And this particular function will allow us to receive fund from the users. Then we're going to build another one. This will call transfer ether. And the last one is going to be for withdraw token, all tokens from the contract. So this is the entire functionality we're going to add in our smart contract. It can be more customizable as per your business logic, but this is the actual contract we generally develop when you will find in all the EVM compatible chain. This is the exact function you will find in all the contract. So we got all of that. Now we can start working on our functionality. So first we have to start with the modifier and then we're going to simply work on other function. So come back to the modifier and here we have to build a condition check. So we'll take this required and here we're going to build the condition. So message.sender is going to be equal to owner. So that's the check we are doing. If it's not the owner, then we have to simply throw the error message. Only contract owner can perform this action and let's close it. So if it's not owner, it's going to throw this error message. That's the check we are doing. If it matches the check, then I want to continue the other function. So for that in Solidity, we use this particular dash notation. So this particular dash notation means that if this statement is true, then go ahead and continue the other function where we're going to attach this. If you are not familiar with Solidity, just follow along with me. You will understand everything. Or you can check this particular course which I have where we're going to learn every single thing about the Web3 from 0 to advanced. Let's come back here in the modifier. We are done with the modifier. Now we have to deal with the constructor. In that we have to simply update the address of the owner. So we have this owner for deploying the contract. We're going to use that particular wallet address to assign as an owner. So we'll say message.sender. So we got our owner. Now we have to simply work on this particular function for updating the token address, and it's going to be a very simple one. It's going to take the address of the token and that's what we have to update. So let's receive the address and we'll call it token address. Once we have that, and it's going to be a public, we'll say only owner because this function can only call by the owner, and that's obvious. You don't allow anybody else to call this function. So let's remove this one, and in that we can simply update that. So we already have this state variable token address and we're going to simply update that. So that's how we can update the address of the token. We got it. Now we have to do exactly the same thing with the token price, but it's going to be a UNT variable. So we have to receive a UNT, the amount of the price. So we'll say token sell price, public only owner, and here we have to simply update that. So our price is updated. Now we have to build this multiplier function because it's going to calculate and do a multiplication, and that's what we're going to return as a final number. So we'll take this, let's say UNT, call it X, and this will be Y. It's going to be an internal function, and we'll call this one pure, and it's going to return a third variable which is going to be a UNT variable called Z. Perfect. And here we have to simply build a condition and do a couple of check and do the multiplication. So we'll take this, and here we have to build the condition. So first condition is going to be Y equal to 0, or we'll take this bracket. Inside that we'll say Z equal to X multiplied by Y. Then we have to simply divide that number by Y equal to X. That's the simple condition we have. We have to simply pass a 2 number and it's going to simply do this 2 check. If any one of these two checks is correct, then it's going to simply return a number. Now we're going to simply utilize this function into our buy token function. So now we can start working on buy token. In that, we have to simply receive the number of token user wants to buy. So it's going to be a UNT variable, token amount, public, payable, because there is a financial transaction. That's why we have to use this payable keyword. And here we have to do the check. So we'll take this condition, require statement. Then I can say message.value should be equal to the amount of the token and user wants to purchase. So we have to perform the multiplication. So we have to multiply with the actual money which user is providing and the number of token user wants to buy. So if the user wants to buy 10 token, so we have to multiply with the price and get the actual amount, and then we have to compare it. So we have this multiplier function, simply copy, and that's what we paste. And in that we have to simply pass the both amounts. So first is going to be the token amount which we are getting from the input. Now we have to simply pass the token sell price. I hope you guys can understand the logic what we are doing here. So that's what we are passing, and it's going to give us the actual value which user going to pay. We have that. Otherwise we have to simply throw the error message. We'll say insufficient ether provided for the token purchase. And here I've done a typo. Simply remove this extra k and it will fix the issue. And this is the what exactly name I have given. So we are done with this first condition check. Now we can simply come back here, and here we have to do the second thing. So we have to inherit the interface of ERC20 token. So we have this ERC20 token. We'll call it token and we'll call the interface. In that we have to simply pass the token address which we already have. So by the token address, in that way I can able to inherit all the functionality we have taken in our interface. You can see all of this function which we can access and utilize it for checking the symbol, supply, name, transfer, allowance. That's all we can utilize it. So we can come back here. We got it. Now we have to simply build a condition. So we can call it token amount should be less or equal to the number of token we have exactly in the contract, because we have to pass the token into our ICO contract. So it's going to hold the token, and when the user will purchase, it's going to take the token from the ICO contract. So we have to check the balance, that is there any token, is there enough token to complete this buying. So we already have the data. We'll call it the balance of contract address. We can call this address this. In this way we can able to find the address of the contract. I am simply remove this and I will throw the error message if there is no token available in the ICO contract. So not enough token left for sell. We got it. So simple condition we have here. What I am doing here, I'm taking the amount of token user wants to buy, then I'm checking the balance available in the contract. If it has enough balance, then we have to make the purchase, otherwise we have to throw the transaction error. Then I can simply come back here. Now it's time to transfer the token. So first I will transfer the token. So we'll take this token transfer. In that I have to pass the message.sender is going to be the recipient and the amount of the token he wants to purchase. So this amount we have here, so we'll say token amount which he provided, and have to simply multiply with 18 decimal point. So we can simply give this notation 1e and 118. So it's going to take ether. Perfect. If the transaction is succeed, then it will go to the next step, and where I have to transfer the fund to the owner of the contract. Means I'm the owner, so I'm going to receive the fund which user paid for buying the token. So it's very simple, payable owner, and we have to call the transfer function. In that we have to simply pass the message.value so I can receive the fund. You can see how easily we are build this logic. Looks great. Now what I have to do is at the end I have to simply increment the number of tokens sold. So we'll say sold token, I have to increment the amount. Perfect. So this is the entire buy function we have for our ICO. So user can simply give the amount and they can buy the token. Now we have to work on this get token details. So it's going to be a very simple function. It's going to return all the details about the token which we are selling through this ICO. So it's going to be called public view and return, and it's going to return bunch of data. So first I want to return the string which is going to be the name of the token. The second one is going to be the symbol, and the third one is going to be the UNT variable which is the balance, and fourth one is going to be, let's call this supply, and fifth is going to be token price, and the last one is going to be the token address. So these are the data we are returning from this particular function about the token. Now we can simply come back here, and all we have to do is to use the interface. So we'll take this ERC20 token and we can simply get it. So we'll take this ERC20 token and we can pass the token address. So we can get the interface. Now we can simply access all of the data about the token. So we can come back here. We'll take this return, and I'm going to return entire data. So first I want to return the token name. Second one is going to be the token symbol. I have to give this comma instead of this. And then I have to simply take this token balance. In that I can simply pass the address this, so I can know that how much token is available in the ICO contract. Then I can come back here. I can check the total supply. After that I can simply call the token sell price, that what is the price of the token, so I can display in the front end, and at the end I can display the address. That's all the data we are returning from this particular function, and just give this comma. Perfect. And that's the only thing we have to do here in the get token details. We got all of this function. Now we have to work on this transfer to owner. So this particular function will be used for receiving donation. So we can come back. It's going to be a very simple one. So we'll take this UNT, and it's going to take the amount, external, payable, and all we have to do is to check for the condition first. So we'll take this message dot value greater or equal to the amount. If it's not, then we have to simply throw the error message that insufficient fund sent. After that we have to simply make the transaction and transfer the fund to the owner. So we'll take this call boolean success, and it's going to return either true or false. So we can simply do the transaction. So we'll take the owner. I can simply call the call method, and I can pass the value, amount, and I can simply call this. So it's going to make the transaction, and it's going to return either success or failure. So I can do the check here. So I'll take this required statement, and we'll say if success is a true, then go ahead. Otherwise simply throw the error message that transaction failed. And that's the function we have to write here in the transfer owner. That's the only thing. It's going to take the amount and it's going to transfer to the owner address. If you want to convert this function to any address, so you can simply take the address as an input, and that's what you can attach. But I'm just restricting this to owner address because we want to receive donation. So we're done with that. Now we have to simply work on the next function. So simply copy this one. This is the exact function which we're going to simply paste here. Then I'm going to receive the address. We'll call it payable. This will be called receiver, and amount. Perfect. This particular function used by the users. They can use the function to transfer the ether to any address. Perfect. Now what I can do, external, payable, and here I can do that. It's exactly the same. Amount is same, and here we have to do nothing because all we have to do is to simply pass the recipient address, and the fund will be transferred successfully. So we are done with this. Looks pretty good. Now we can simply work on this withdraw all token, and this particular function will allow us to withdraw all the token we have in the ICO contract. Because in future, if you decide to destroy the ICO contract and you no longer want to use it, so before you destroy, you should withdraw all the token. So let's build that condition. Public only owner is allowed to withdraw all the token. So we'll remove that, and we'll call this ERC20 token. We'll call the ERC20 and pass the address. We got the interface. Now we have to check the balance, that how much token is available, because if there is no token available, we don't want to execute the function and cause unnecessary gas cost. So we'll take this balance, and we can access the balance and check that very easily. So we have this token, we can call this balance off, and we can pass the address of the contract. So we'll say address this. So it's going to give us that how much balance is available. If we have enough balance, so we're going to build a if statement. So we'll take this condition. We'll say if balance is greater than 0. If balance is greater than 0, then execute the transaction. Otherwise, throw the error message. No token to withdraw. Perfect. And we can simply come here and we can say transfer. We can transfer the entire token to the owner address. So we'll say owner, and this is going to be the amount, balance, and we'll say transaction failed if anything goes wrong. And that's the entire smart contract we have for our token ICO. So this is our interface. This is our state variable. You can see our contract is very light but very powerful, and it's provide all the features related to the ICO. This is the modifier, this is the constructor, this is the update, sell, multiplier, buy token function, and we have get token details, transfer ether, and withdraw all token. I hope you guys have understood that how everything is coming together. Very small but very powerful. Now we have to work on our ERC20 token. So we can come back here, and we have this here, ERC20 token. Click here, and that's what we have to work now. So it's going to be a very simple function. I hope you guys are already familiar with ERC20 token, that how you can create. We're going to use OpenZeppelin for this. So let me quickly import the library. So I'll say import, and we are using OpenZeppelin. So we have imported our OpenZeppelin. Now we have to simply call the contract. So we can say contract. You can call whatever you want to your contract. So I'll say the blockchain coder, and I want to inherit the ERC20 interface from the OpenZeppelin. So I'll say ERC20, and here I have to simply call that. So I'm going to use the constructor, and I'm going to build my token. So we'll take this ERC20 token. I have to give, and in that I have to give two things: name of the token and the symbol. So I'll call this the blockchain coder. You can call whatever you want to your token, and the symbol is going to be @TBC. So this is what I have to provide. Now I have to simply mint the token, that how many token I want to create and who actually going to inherit being the owner of this token. So I'm going to make myself as an owner of this particular token. So I'll take this mint function, which is coming from OpenZeppelin. In that I have to pass two arguments: the address, which is going to take hold of all the token. So I'll say message.sender, which is going to be me, because when I will deploy the contract, I'm going to be the owner. And the second argument is going to be the total supply. So I'll give 1, and I'll give 18.0. When you will give 18.0, it's become 1 ETH. Okay, so I'll add more 0. So let's call this 0.0.0.0. And if you want to know that how many token is going to create, you can simply use this powerful online calculator, which allow you to calculate from Wei to Ether. So simply copy this one, come back here, and by the way, all the resources are already given to all of you guys. Check all the project we have on our channel, and all the resource starter files are given, so you can simply download the starter file and start following the tutorial. So click on the new tab and type Wei converter. Click on this, and you can simply use this calculator to calculate that how many token you're going to create. So whatever we have copy, you can simply paste here, and you can see we're going to create this much token. So simply copy, and that's copy this, and that's what you have to provide. Perfect. And we are ready to create our token. Make sure to give this, and we are ready. So this is how we can create our ERC20 token. So we are done with both the contract. Everything is looking great. Now come back here, close this one, and now we have to work on our functionality, which allow us to communicate with our contract. So before we start deploying, I just want to build out all the functions. After that, we're going to deploy and do all the testing. So let's write those utility function and all the function which allow us to communicate with our blockchain and the smart contract. So first, what we're going to do is we're going to start working on the utils function, and it's going to be a very simple one. In this, I have to write two functions. One is converting for time, and the other one is going to be for short address. So let's write that time converter first. So we'll take this and call export convert time, and here I have to simply convert the time. So I'll take this date, new date, and in that I have to pass the time, and I can simply construct the time which I want to return. So you can construct as per your requirement, but this is the standard we follow when we are working around the decentralized app. So I'll call this formatted date, take a template literal. From there I can access the date, and from there I'm going to use this to local date string, and I want to have the time. So we'll say date to local time string, and that's the only thing we have to do here. So all we have to do is to simply pass the timestamp, and it's going to convert the time. Perfect. And at the end, I want to return this. So we'll take this formatted date. Now we have to work on the next one. It's going to be the short address. Let's call this shorten address, and it's going to take the address as an input, and I have to simply convert it into a small address. So I can take this template literal. I can simply call this address, and I want to use the slice method. So I want to take the first 4 character of the address. So I'll take the 0, 4. And I want to take the last 4 character. So I can use this same method. So I'll take this address, and I want to do the slice. But this time I have to calculate the entire length of the address. So we have a method called address.length, and I want to simply subtract with -4. So it's going to give me the last character of the address, last 4 character of the address. So that's the only thing I have to do. I hope you guys have understood. It's very simple, and we have used the same function multiple times in our other project. So now I can come back here. We are done with this. Now we have to simply start working on our other function in the context, and it's going to be quite huge. So click here, and here we are in the constant, and you can see this is the entire network I have already given. So you can literally deploy your contract to any network, but in this I'm going to deploy to Hostclay. It's the Ethereum test network because I have test fund in that, so I can test it. Polygon MOI is no longer working, it's depreciated. You can use Polygon MOI or mainnet, testnet. So we have a bunch of network. Make sure you should have some fun, then you can able to deploy. But this time I'm going to use this Ethereum test network. So all of this configuration is already given to you in the starter file. So now what we have to do is we have to quickly install the packages, import the packages. So we can bring this bound, and I want to simply import the package. First is going to be the Ether coming from Ethers. Then I want to import Web3 model. So make sure to give W capital Web3 model, and it's coming from Web3 model. Again, I will show you other way of connecting with the wallet. So we have Wing, which is a powerful React framework library which allow us to communicate with different Web3 wallet providers. So we're going to use that as well. So first follow along with me, you will understand everything. So we got this package. Now we can come back here and we have to import the libraries and the addresses. So we'll call this import token ICO, and we can access that from token ICO.json. So it's going to contain the ABI of our contract, but right now we don't have it. So let's inherit the ERC20 ABI, which is coming from ERC20 JSON. So these are the two ABI we need for two different contracts. So I can come back here and you can see we have only ERC20, but I don't have the token ICO. So I can create a copy and create a file and JSON. Perfect. So we got this two JSON file and two files. So close this one. Now we have to simply take a variable. So we'll say export const, and it's going to be our token address. So we haven't deployed our token yet, so I'll just keep it as an empty. We're going to deploy and we're going to provide the address. Then ERC20 ABI, and that's what we're going to simply provide here. This is for the token. Now we have to deal with the ICO contract. So we'll take this owner address, the account which you will use for deploying both the contract. That's the address we're going to provide here. After that, we're going to use the ICO contract. So we'll take this ICO contract address empty, and it's going to be our ABI of our ICO contract. So this is how you can inherit. So you can simply give the ICO token ICO and you can call it ABI. That's how you can access the ABI of the contract. But currently we don't have it. Just keep it as it is. There is no problem in that. So we are importing all of this, which we're going to provide it after deploying our contract. Now we can simply come back here and start working straight away on the functionality. So we're done with this addresses, the network. Now we have to configure the network which you want to use it. So the user can only use your contract on a specific network. If they want to interact with different network, it's not going to work, and we're going to prevent any kind of error or hack in our contract. So that's what we're going to do now. So we can come back here. So this is the network setup, and I'm going to configure the application based on this, but you can literally do exactly the same thing for other network as well. So if I open this one, these information are very important. So you have to simply change the chain ID, network name, symbol, decimal point, and RPC URL. So these are the things you have to provide relevant to that particular blockchain, and everything would be working fine. But I'm going to use this particular network. Close this one and come back here, and now we have to do the network configuration. So first I'm going to build a function which allow us to simply change the network. So if the user is connected on say Polygon and my contract is deployed on Sofali, so I want the user should interact with Sofali, not with a Polygon. So it's automatically going to change the network in their MetaMask. That's the function we are building. So it's going to be an async and receive the network name. So we'll call it network name, and here we have to build the logic. So we'll take this try and catch. If anything goes wrong, we have to simply console log out that error.message. We got it. You can come back here, build the if statement, and first thing we have to check whether the crypto wallet is available in the MetaMask or not, because when you will install any crypto wallet, is going to inject the Ethereum object, and that's what we have to find out. So we'll take this window. If window.ethereum is not there in the browser, then we have to simply throw the error message. We'll say that no crypto wallet found. That's the first check. After that, we have to simply call this window Ethereum, and we have to make a request. So we'll call this request, and we have to fill this param. So first thing is going to be the method, that what type of method we want to call it, because in the MetaMask API you will have multiple options. So here we have to provide that particular method which we want to use it. So I'll call this wallet dash address add Ethereum chain, not chain. Then I have to provide the param. So it's going to be an array I have to first deconstruct it, array of object. I have to simply spread all the data which is there in the network, and from there I can give the name. So I'll take this and pass the name, and that's the only thing you have to do. This network will contain all of this information. Perfect. That's how we can able to change the network. Looks good. We are done with this particular function. Now we have to build other supportive function. So we can come back here. Let's build this export called handle network switch. So all I have to do is to simply call this change network function in this particular one, and I can simply call this function wherever I want. So it's going to be anything. It will come here. We can simply call this network, and all I have to do is to pass the name of the network which I want to connect. So I'm going to use this one. So I'll take this string and I'm going to use this network. So I'll call this await change network, and I can pass the network name. So I'm going to deploy and test my contract on this one. Copy this one, and that's the name you have to pass. You have to do exactly the same thing if you are using any other network. So this is our network configuration. Close this one. Now I can simply, we are done with this. Now copy this and paste here and change this to check wallet connection. And this particular function will run every time whenever the user will try to interact with our application to check there is a wallet connection is available or not. Then we can only allow user to make the connection with our smart contract. So we have this, remove this one. Now we can simply come back here, take this particular one because we need this to check the wallet is available. After that, we can simply remove this and we can simply return the error. So we'll say console.log. Once we're done with that, we'll say please install MetaMask. Got it? Now we can come back here and we can take this await, and we have to call the function we have built. So we'll take this handle network switch, and that's the only thing, because when this particular function will run, it's going to check whether the user is connected with the exact network or not. If it's not, then it's going to call it and switch the network. Otherwise, it's going to continue as it is. Perfect. Now we can simply come back here and we have to get all the address which is available in the MetaMask. So we'll take this accounts, await, window, Ethereum, and we have to make a request, and here I have to provide the address. So we have multiple address. So first we have to provide the method. We'll say ETH accounts. That's the method we have to call. It's going to give us the array of accounts. So I have to get the very first account. So we'll take, if there is a length of accounts, means there is a array, then I want to simply get the first one and simply return with the function. Else I want to simply throw an error. We'll say please install MetaMask and connect, reload. Perfect. And that's the function we have for connecting wallet. Check wallet connection. Close this one. Now we have to build a next function called export cons. We'll call it connect wallet. So it's going to take click event. So when the user will click, it's going to simply connect the, that's going to be an async function. Let's take this try and catch and console log out the error object. And we can come back here. We have to do the exactly the same check. So I can take this portion and take the entire one and paste here. Take the entire portion and paste here. And here we have to do a little bit of modification in the method. So we can simply come back here. First thing, this is going to be exactly the same. And here we have to do the changes in the method. So this will be called ETH request account, because we're going to call this function based on the click. And instead of checking for the length and all, I can simply do the window.reload, because when we'll call this particular function, is going to connect the wallet and it's going to reload. So when it's going to reload the page, we already have the function called check wallet connection. So it's going to simply trigger, because that function is going to trigger every time there is a page reloads, and it's going to set the entire state variable. Perfect. I can remove this, and let's keep this as it is. So we got all of this. Perfect. Now close this one, close this one, close this one, and close this one. And here we have the entire network. Now we have to work on the actual function which allows us to communicate with our smart contract. So we can come back here and we can take this variable called fetch contract. And this is going to be a reusable model, because we have to use the same function in our token contract as well as in the ICO contract. So it's going to take a couple of arguments. It's going to be take the address of the contract, ABI of the contract, and the signer, means who is actually interacting with the contract. So we're going to use the ether package. So we'll take this new ethers contract, and in that I can simply pass all this data. So it take the address, ABI, and the signer. This order is very important. So when you're going to pass the function, pass the data, you have to pass the data in the exact format. So we got this internal function. Now we can come back here and build the actual function which is going to call our ICO contract. So we're going to simply copy and paste here, and we're going to simply do the modification, change this to token ICO contract, and here we're going to simply remove this portion. First thing, we can simply come back here. We're going to use our web3 model package. So we'll take this const web3 model, and we already have the package, so we'll call this new web3 model, and that's what we have called here. You can see we have called with a capital W, and that's what we are calling, because I have seen that personally a lot of you get confused in the naming convention. So that's what I got it. Simply call that. After that, I have to build the connection. So I can call this connection await web3 model, and we can simply call this web3 provider, and in that I can pass the connection. Then I can simply come back here, take the provider, and I can call this new ether provider. Okay, I made a mistake, so I have to simply cut this one. Like, I already have this web3 provider. This is going to be down below here in the ether provider, and here we have to call the connect function. So I'll call this connect. That's how I can get the connection. Now it's good. Once we have the provider, now we are ready to interact with the contract. So we can come back here. We'll take the signer object from the provider. We'll say provider dot get signer. Once we have all of these details, now we can simply build the contract. So we'll take the const contract, and I can call the internal function fetch contract. In that I can simply pass the data. So first is going to be the address. So we have already taken as a state variable, means on top. Then I have to pass the contract ABI. Then I have to pass the signer object, and it's going to return the contract object. So let's call this return contract. So this is going to be our usual function. We're going to use this function in multiple places like buying, fetching, transfer. That's why I'm converting this into a reusable model. We got it. That's the entire thing we have for token ICO contract. Perfect. No need to do anything in here. Everything is good. Now we can simply close this one and copy, and we have to simply paste here, and it's going to have the similar structure. So I'm going to do the changes. This will be ERC20. Perfect. We have to build the connection and provider. This is fine. We can simply change this to network, and I can simply call this await, and I can change the method. So it's going to be get network. Actually, I need the signer as well. So I can simply replicate this one, and let's call this get signer, and this will be a signer. Now I can simply come back here. I'll take a variable called user address, and I can call this signer, and on that I can simply call this function called get address. So this will give me the address of the user who is trying to interact with our token. Once I have the address, I can simply check the balance of the user. So I can call this await contract, and in that we have the function called balance of, and I can simply pass the address of the user. So I can know the balance of the user in the contract. Got it? Now I can simply come back here and build the entire architecture. So I'm going to take this variable called name, and we already have this function contract name, and it's going to give me the details, and replicate that, and this will be called symbol. This will be the token supply, and this will be the decimal, and the last one is going to be the address of the token. Perfect. So we get all the detail about the token. Now I can do this change here, decimal, total supply, copy. This is going to be a symbol. Perfect. So I got all the details about the token. Now I can come back here, and let's build the data as an object. So that's what we can return. So we can take this const token, and let's build out all of that. So first is going to be the address, which we already have. Then I have to take the name. After that I have to take the symbol. Then I have to take the decimal point. After that I have to take the supply. So we have to convert that supply into a readable format, because it will come in the big integer. So I have to convert that. So I'm going to use ether library. So I'll call ether utils, and we have a multiple method. So I'm going to simply call this format ether, and in that I have to simply pass the amount, so which we already have in the supply, and I have to call this to a string. Perfect. So that's how we can convert it in an actual readable format. So simply replicate that and change this to balance, and here I can simply pass the balance. So this is the balance which I have to simply pass here. Perfect. Now I can simply come back here. This is going to be the chain ID, and I can have this chain ID here, and this is all the details that we are getting about the token. Perfect. and then I want to return this token, and I can console log out this, and I have this. So let's remove this contract. I don't need this. Perfect. So this is our entire ERC20 token function, which allows to give all the details about our token. Perfect. We're done with this entire one. Perfect. If we find that we have to do any modification or we have to add anything, we can definitely come back here and do this testing and fix those. But as of now, it's looked great. So we're done with this. Now we can simply come back here. We are done with this two functions. So simply copy token ICO contract, and that's what we can paste here. Let's change this to ERC20 contract. So now we are actually writing the code for our token contract. So this is going to be exactly the same, and here we have to change the address. So it's going to be called contract address. This will be the contract ABI. So it's going to be the ERC20 ABI. I can simply come back here, and I made a typo. So it's going to be, let's say, ERC20 ABI, not O. So that's what I have to pass, and I have to pass the address of the token. So that's contract we have. Perfect. And this particular address is going to be from the input field. So this is the address we have, contract address. So it's going to be the address of the token. So simply what we can do, simply copy and just receive that in this particular function. And that's the only thing we have to do. In this way, we can able to have the ERC20 token object. So we got our ERC20 token contract. Now we can copy and paste, and let's change this to get balance. It will remove this one, and here we have to simply do one thing, remove this one. We'll call this MATIC balance, await signer. You can call whatever you want. I'll say signer get balance. Perfect. So once I have the balance, I can simply come back here and I can copy this converter function. So simply copy, because I don't want to rewrite the huge line code. Close this one and come back here and simply return and copy and paste here. So it's going to have the balance of the user who is actually connected. So we got this. Perfect. Now we have to write one more function. Simply copy and paste here, and let's change this to check account balance. So this is going to be exactly the same. We have to get the address of the account which we want to use it, and simply copy, and that's what I have to simply paste here. So we have this signer, remove this one, and I can simply come back here, and here we have the signer. I'll call it provider, and on that I can simply call this get balance, and in that I can simply pass the address of the user whose account I want to check, and that's perfect. So this is how we can check any account balance. So this is the entire function, and now we have to write one more function which allows us to add the token in the MetaMask. So we'll call it add token to MetaMask. It's going to be an async, and we already built and done the hard work. So we can simply come back here, and first we have to build check for the Ethereum object. So we have already done this. So if it's there, then I want to simply call this. So we'll take this const token details, and we already have the function. So we'll say the contract ERC20, and I can call the function. In that I can simply pass the token address. Now we have that. I can simply come back here. I can call this token details decimal. I can call the token detail. On that I can simply call the decimal. So in that way I can able to know that what is the decimal, because this is the token we are selling through our ICO and what we have created. Now simply replicate and change this to token address, and this will be the token address. Change this to symbol, and this will be our, let's call this token image. So make sure you have to deploy your image on internet, and that's what you have to provide. I already have a bunch of projects in which I have explained that how you can create your token and deploy all the metadata, including the images. So make sure to watch this video. In that I have explained that how you can build a Web3 tool which you will allow user to use it to create their token with all the metadata. So make sure you have to provide the image URL. I'll give my image URL which you can use it. Now we can come back here. We can simply take this try and catch, and we have to simply take a variable call was added, await, and we have to simply call the method we have. So we'll call this request, and we have to simply give the name of the method. So this time we have to call this wallet watch asset. Then we have to give the params. So it will have all the params. So first we have to define the type. So it could be NFT, it could be token. So we are dealing with the token, so we can say ERC20 token. After that, we have to give the options, and in that going to provide all the details about the token. So we'll take this options, and it will be the address of the token. We already have it. Then we have to provide the symbol. Make sure to order is very important. This is the exact order you have to follow. We'll say token symbol. Actually, we can come back here and I can simply replace this one with a capital S. Perfect. Token symbol. Then I can come back here, decimal, token decimal, and the last one is going to be the image. Perfect. So we got all of this data. Our function is ready. Now we have to handle the response. So if everything is good, like if was added is successful, then I can simply return this message like token added. If anything goes wrong, we can say return this token not added. Perfect. And by default, I can simply return an error message. We'll take this return like failed to add, and we can take this else block here and I can say return MetaMask is not installed. Perfect. So that's the entire function we have for adding. So first we have imported it, taken our ABI, then all the state variable for the token address, honor, and the contract address and the ABI. And here I have this. Let's remove this one for just keeping you any confusion you might have. So let's clear everything because right now we don't have ABI, don't have addresses. So just make it empty. This is the entire network configuration I've given. I've given you multi-option. Here we have the first function, second function, correct wallet, fetch, and all of this function we have coded. Everything's looking great. So we are done with this entire one. Now we have to start working on our index, the context management. So come back here. Let's click on this index, and that's what we're going to work next. So first we have to import packages. First we have to import React. In that we need use state because we have to manage our state. It's coming for React. Then we have to import our Ether package that's coming from Ether. After that, we have to import our toaster to displaying the notification coming from React hot toaster. Then we have to simply do the internal import of all the function that's coming from our constant. So we can come back here, and first thing we're going to simply import is this one, check wallet connection, copy and paste here. Then we can come back here. Second is going to be wallet connect, paste, come back here and get balance. Let's quickly import all of the function. Then we need this, and we need the address of the token, and we need this function copy. So this is all the imports we are doing from our constant file. So we got the functionality. Now we can simply come back here and let's build the provider. So we can say token ICO contract. We'll take this React create context. Then we have to build the provider. Token ICO provider is going to take the children, instant return, and in that we have to build all the functionality and declare all the state variables. So let's start with couple of state variables. So first is going to be the, let's say, DApp name. You can literally call whatever you want and you can display in the front end. So I'll call it token ICO DApp. The second is going to be our, let's say, currency. So I'm going to deploy to Ethereum, so I'll say ETH, but you can call it whatever you want. And the third one is going to be, let's call it network name. These are the additional variable I'm taking. If you want to use any other, you can definitely use that. So let's come back here, and here I have the network name. So this is the one I will copy because where I'm going to deploy and make it capital. So these are the additional state variable I have taken. Now I can come back here. Let's take a state variable. First is going to be loader. By default will be false. Second one is going to be our account. It will keep the account. Then I'm going to take another one. This will be called count. By default will be 0. Then I can come back here. Let's work on the notification component. So we'll take this notify success. We are using this particular library. In that we have to pass the message, and it's going to be an instant return. So we have a method. So we'll call it toaster success, and it's going to take two arguments, the message and the duration. So I'll pass the message, and I have to pass the duration, that how long I want to display the notification. So it's going to be 2 seconds is enough. This is for success. So it will have a green color. For error, I can take it, simply copy and paste and call it error and change this to error. So it will display in red color. Perfect. We got this. Now we can simply come back here and start working on the functionality. So let's build the very first function called token ICO. This particular function will give us all the information about the token, which is there in the ICO. So it's going to be an async. We'll take this try and catch and we can console log out the error. So let's build the entire skeleton of all the functionality we're going to have it. So let's close this one and we can simply copy this one, paste here and change this to buy token. Copy, paste here. This will be called token withdraw. Copy, paste here, and this will be update token. Copy, paste here. This will be let's call this one update token price. Copy this one, paste here. This will be called donate. Copy, paste, and this one is going to be transfer ether, and the last one is going to be called, let's say, change this to token. So this is all the function we're going to code it together. So let's start with the very first one. So this is what we have. Now we have to first, what we have to do is, let's give this comment contract function. So first we have to get the address and check the user is connected or not. So first, for that we already built the internal function. So we can come back here, take a variable called address, and we're going to simply call the internal function we have built, check. We'll say await check wallet connection, and it's going to return the address of the user, and based on that address we have to make the function call. So we'll take this if statement. We'll say address is there, means user is connected, then I want to execute this function. Inside that I will take this loader to true. After that I can simply call my address and set the address to our state variable set account, and then I can simply call the contract. So take the contract and I can call the token ICO contract. So I will have the entire object of the contract, then I can perform the actions. Once I have the contract, now I can simply come back here, take the token details, and I have to get all the information about the token which we are providing currently in the ICO. We'll say await contract get token details. So this is the function we have built in our contract, and that's what we're going to call it. This is the function. Simply replicate this. Now I can take the owner, then I can take this sold token, and all of this we are getting from our contract. So let's change this to sold token. This will be the contract owner. Perfect. We got all of that. If you want to check, you can come back here, go back to the contract, and there you will find that this is the function we are calling. This will give us the information about all the details about the token, and the rest of the information about the owner and the sold we are getting from top. Perfect. Now double check the spelling that you are calling exactly the same name. Once you have that, now we can simply come back here and we can build the structure. So first thing, I can get the balance. So I want to check the balance of the user. So we already have the function. We'll say get balance. Then I can come back here. I can take a variable called token, and I'm going to design the data which I'm going to return from this particular function. So first thing is going to be the token balance. We'll say ethers utils, and I have to format that. So we'll say format ether. It's going to take the token details, the balance. In that token details we have the balance, and I can convert it to a string. Perfect. So that's how I can get the token balance. Then I have to get the name which I already have in the function. Then I can take the symbol token dot symbol. After that I can simply copy this one and that's paste here and change this to supply, and here I can change this to, let's say, supply. Perfect. Now I can come back here, change this to token price, and I can change this to token price. Then I can simply copy and paste here, and this will be called, let's say, token address, and this will be token header. Replicate it. This will be ETH balance. Change this to MATIC balance. You can call whatever you want. Change this to address, and this will be address, and convert it to a lowercase. So we can simply match in the front end because we have to check the owner, and based on the owner and the normal user I have to restrict certain function and certain component. So that's why I'm taking in lowercase. So it would be easy for us to simply match the address and confirm that verification. So make sure to give the exact variable name which I'm doing. Once you complete the project, after that you can do the modification and change the variable name. That's what I have. I can simply change this to contract lower owner and honor, and this one is going to be sold tokens, sold token, and it will be a number. So that's all we have here. At the end I would just want to set the loader to false, and I would just want to return the entire token details particular. Perfect. So this is the entire function we have. I hope you guys have understood. It's very straightforward. All it's doing, we are getting all the information from the contract and simply displaying. So we are done with this token ICO. Now we have to work on this buy token, and it's going to receive the amount from the user, that how many token user wants to buy. Then I want to do the same thing here. So what I will do, I can simply come back here in the token ICO and I can grab this portion, close this one, copy, and I can simply paste here, and I can do the modification. So like what I can do, I can simply remove this, and I can simply come back here, and I don't need this, but still I want to check the user is connected, so that's fine. I can simply check, cut it and paste here. Then I can simply come back here. I can simply do one thing, come back here. Actually I need one more function, I deleted by mistake, so simply copy this one, and that's what I can simply paste, because I have to check the supply, that how much supply is available. If it has enough supply, then I want to execute it, otherwise I have to throw the transaction. So we are doing this check in two places, within the contract and in front end. So it would always great that you can take this approach. Perfect. Now we can simply come back here. We'll say available token, and this detail we have available in the token detail function. So we'll take this ether utils format ether, and I can pass that token details, and from there I can access the balance, convert it to a string. So this will tell me that how much token is available. So we'll say build a condition. We'll say if token available balance is greater than 1, then I want to execute it. So in that I can simply take a variable called price, and I have to convert it. So simply copy this portion and paste here, and I can simply pass the price, which is already there in this data. So we'll take this token price. So I have the price. Now I can simply come back here. We'll take this pay amount, and I have to simply perform the transaction. So we'll take this ether utils parse, let's call this units. In that I can simply pass the price, and I can pass this ether, so it will convert into ether. Perfect. Now we can come back here. We'll build this transaction. We'll say await contract.balance contract.buy token. This is the function we have built. If you come back here, this is the function we are calling. So buy token. In that we have to simply pass the token. Make sure to be in number, because that's what we have defined. So it will be the amount, and I can set the extra variable. So I have to send the value. So value is going to be pay amount and convert it to a string, and I can also set the gas fee. So I'll go with this one to have a safest transaction. Okay, so I'll go with 8 and give 660, because I have found that when I give this gas limits, transaction get execute. Perfect. Now we have to simply wait for the transaction to complete. So I'll use this wait method. Once the transaction is complete, I can simply set this notification, transaction completed successfully. After that I can simply set the window to reload, and I can simply remove this, actually cut this one and cut this and paste here, because I have to display and remove, close the loader as well, and the rest would be fine. I can simply come back here and I can display the error if anything goes wrong. So I'll take this notify error, and I can say error trying again later. I can say take this set loader to false. Perfect. So this is our entire buy function. Pretty big but very effective. We got with this two function, copy and paste here as well. Perfect. So we are done with this two function. Now we have to work on the token withdraw. So it's going to be a very straightforward. So we have to do exactly the same thing what we have done in buy token. So we have to do the couple of checks. So we can come back here and we can simply grab this portion, copy that one, and that's what we can paste here, and make sure to close this if statement. This is what we got it. Now still I have to check the available supply. So I can simply come back here and I can simply grab this as well, and that's what I can paste here. So I have to check the available supply of the token. Now I can simply build a statement. So we'll take this await transaction wait, and we'll set this set loader to false, and at the end I want to reload the window. Okay, I made a mistake. I have to build the transaction object. So I can simply come back here and I have this one. So this is the entire if statement we have. Simply copy, and that's what I can simply replace here. So simply paste here. So we are checking that if it's available. Here we have the price. We don't need this. Remove this one. And here we have the one. Remove this one. We don't need that. And now we can come back here. This is the function we have copy, and that's what we have to simply call here. And we don't need to pass any argument. So simply remove all of this. Because when you are making any changes in the state in the smart contract, then you can simply provide that. But here we are simply withdrawing everything. So we don't need to pass anything. And the rest to be fine. So this is how we can simply withdraw all the token from our contract. Perfect. So we're done with that. Now we can simply start working on this update one. And this one is very important. When we'll deploy our contract, this is the very first function we have to call, update token, and the update token price. This is the two function we have to call it. Otherwise, nothing will work. So we can come back here and we have to work on this update token. So it's going to be a very straightforward. So simply copy this till here and close this one. And we can simply copy this one, token withdraw one, copy and close this one. And here we can paste it. So still we need to check the address. We can simply, let's remove this one and remove this one. So we need this transaction setup. All we have to do is to simply pass the details. So we can come back to the contract and we have this particular function called update token, copy. Is going to take the address. So we can receive the address in this function. And that's what we can simply pass here. And we can simply come back here. The rest would be fine. Don't need to make any changes. This is fine. Simply copy. And that's the exact thing we have to do in the next one, in the price one. So instead of address, it's going to take the UNT variable. So we have to do a little bit conversion here. So this is fine. Like we can come back here. We have to convert the price. So ether utils will say parse unit, and that I can simply pass the price and string and ether. And this price is coming from the input field there. And that's what we're going to receive. This is the one we have to call, paste here. And that's the price we have to simply pass here. So this function is ready, which allows us to update the price in our contract. So we're done with that. Copy this one, close this one, and that's what we can use in the donate one. So simply paste here. And we can do the exactly the same thing. So we receive the price which user wants to donate. So we'll call it amount. And that's what I can simply paste here. So we have to convert it. Once I convert, I can simply pass that to the function. So pass here. So it will take the pay amount, and I have to simply provide the additional information like the value, the money the user is transferring. So convert it to a string, and I can define the gas fee. So I will go with the exact value 860. So we are done with that. So looks fine, and the rest will be fine. All you have to do is to pass the amount and the value, and the rest will be fine. Copy, and that's what we have to do here in the ether as well. Simply paste here, and it's going to take two arguments. So address where we want to transfer and the amount. So this is fine. We can simply receive as an object. So we'll call this transfer, and I can deconstruct this because it will come as a data of object. So we can come back here. We'll take this const transfer, and that will have two information: address means the receiver address and the amount. And that's what amount I can simply come back here, pass here, and I have to simply copy the address, and I can simply paste here, and the rest to be good. Now if I come back to the contract, here we have the function called update token sell price, and here we have this transfer ether, copy, and that's what I'm calling here. So simply change this to transfer ether. Perfect. And the rest to be fine. And I notice one thing, that I have to do the changes here as well. So I can simply come back here, and this is the function we have to call transfer owner, because the donation will go to owner, copy, and that's what I can paste here. Perfect. So we got done with this two function. Now we have to work on the last function. Simply copy this one, close this one, and paste here. It's going to be a very simple one. I just want to give you a try. I hope you guys have tried and you have succeed, but let me write it. So this is going to be exactly the same. Like we need three information. So I'll take this transfer. It's going to take receiver and sender, where we want to send to. Then, and this is fine. I can change this contract. This time I have to interact with the ERC20 token contract. So let's change this to ERC20 token contract. And I still need to convert the amount. Yes, I want to convert that. And this receiver I want to simply pass. This will be called to token address. Because when I will pass this token address to the contract, it's going to become that particular token object. Simply copy, and that's what we have to pass. Perfect. And this is the amount I have. This is the amount I'm passing. Perfect. Now I can simply come back here and come here. This is the function we have. Let's change this function. Call transfer. And here I have to say send to. Perfect. And the rest will be fine. We don't need to make any changes. Everything looks great. But we don't need to send the amount because this time we are transferring the token and all the calculation is going to be in the contract. So we don't need to pass any value. Perfect. So we're done with this. All the functionality is ready. Now we have to simply export the function we have built. Perfect. I hope you guys have followed along with me. And if I come back here in the buy token and we have this error one, and I haven't provided this in other functions, simply copy this one and let's provide that. Come back here in the token transfer and let's give this. Close this one. Let's go to the next one, Ether, paste here. Close this one, come back to the donation, paste. Come back to the update price and paste. Come back to the token, paste. And we have the withdraw. Let's do the same thing here as well. And we are done with that. So we are done with all of this function. Now we have to simply export. So we can come back here, we'll take a return. And we're going to simply build our context provider. Let's close this one. And inside that we have to simply pass the children. And here we have to simply pass all the as a value. So we'll take this value as a form of object and then we have to simply export all of the function, all the variables we have built here. So first is going to be our token ICO, second buy token, transfer ether, then we have donate, then we have update token price, token withdraw, transfer token, connect wallet, ether, ERC20, check account balance, set account, set loader, add token to MetaMask, token address, loader, account, currency. So we got all of this function and the variables we are exporting from this particular function so we can utilize in our front end. Perfect. Just have a quick overview one more time. So this is the packages, this is the function we have, this is our context and the provider, state variables we have taken, and we have all of this functionality. Looks pretty cool to me. So we have the token and all of this looks pretty beautiful. Now we can start working on the app.js. Close all of these tabs. Now we can come back to the pages. There you will find we have to do our context management setup. So I have already done the setup for the JavaScript files and all the internal libraries we are utilizing. Now we're going to simply deal with the data. So what we have to do is first we have to simply import our toaster package because we have to display the notification and that's coming from the toaster like React hot toaster. Once we have that, now we have to simply import our context management. We'll take the import and that's coming from our like /context index. We already built this one. So like come back here. If you go back to the context, this is what we have. So you can simply grab this particular portion like this one and that's what we have to import here. Perfect. And now we have to simply wrap our entire application with that particular provider. So we can simply do that very easily. And let's close this one. And I want to simply import the toaster here as in a global object. So let's import this. And that's the only thing we have to do here. And definitely we're going to do more setup here when we're going to attach our like Wing wallet provider, which allows us to communicate with different wallet providers. We're going to add a couple of more code, but as of now, let's go with this particular approach. Perfect. That's the entire setup we have done. I hope you guys have followed along with me. Everything is looking great to me. Close all of this, close this one, close this one, close this one. So we are done with all the feature in our context management. We have written a lot of utility function. This is the constants, this is the index. And now we have to get our ICO ABI, ERC20 ABI, and we have to simply deploy our both contract. So let's start with that first. So what we're going to do is first we're going to deploy this particular token contract. After that, we're going to deploy our ICO contract. So before we deploy, we have to do a couple of setup, and actually we have to configure this particular network where we are deploying in our MetaMask wallet. I believe that most of you don't have this particular network in your MetaMask. So let's configure this first. So first come back to the browser, and now you have to open up your MetaMask first. And you can see I'm not logged in, so I'll simply type and I'm connected already, and I already have this much fund. So you can see I'm already connected with that exact network and it's already reflecting. But in your case, this network might be not here. So what I will do, I'll simply change the network and I'm going to delete the network to show you how you can configure that. So first I'll simply click and delete. So I've deleted the network and the network is not there. but I'm going to use that particular network. So to configure that, you can simply click on this add network. You will come back here. Here you will find all the setup of your MetaMask. You can simply come back, go to the networks, and there you will find all the network which you have configured. There is no network available for that particular one. So what I will do, I'm going to add that network manually. So click on this add network, and here you will come, click on this add network manually, and here you have to provide all of these details like name, RPC URL, chain ID, symbol, and explore URL, which I have already provided to all of you guys. So this is the exact data we have to provide. So what I will do, I'll simply copy this one, exact name, and that's what I'm going to give here. Got it? Now we have to simply get the chain ID. So I'll simply come back here. I can simply provide the chain ID, and I have to provide the RPC URL. So I can come back in the code, and I have to provide the RPC URL. So make sure you have to use the exact website, exact RPC URL. You can see I'm using this particular website, and you have to use the exact website for getting the RPC URL. This RPC URL might be changed after 3 years or 4 years, but make sure to always double confirm. This is what I'm using. You have to use the exact one. Copy, and that's what you have to provide here, RPC URL. Now you have to give the symbol. So here it's suggesting you to add ETH. So let's add ETH. Now let's come back here, and you have to give the explore URL. So here I got this URL from the Etherscan for this test network. Copy, and that's what you can simply paste and click on save, and click on the switch to test network, and got it. You can see I'm back to the same network. I already have this much fund, but in your case you might not have this fund, because this fund is very important if you really want to deploy and test your contract. So to get the test faucet, you can simply open a new tab and type Google Cloud Web3. Google have started their Web3 where you can able to get the free faucet. So it's one of their products. So you can click on this Web3 faucet, and you will come back to this particular section. You can click here, and here right now they are providing two options, Sofali and Hoskey. I hope I'm pronouncing this correctly. In Hoskey they are providing 1 ETH, but in Sofali they are providing like 0.5, which is very less. So I'll go with 1 ETH. Click on, and here you have to provide your wallet address. So I'll simply come back here, and I'm connected. I'm using the exact address. So I'll simply copy the address, and then simply paste the address here, and I will simply click on this receive. So it's going to simply transfer the token to my wallet address. So you can see the transaction is taking place, and it's happening. Once the transaction will complete, the fund will be reflected in my wallet, and I'm going to use the exact wallet to get the and deploy my contract. So you can see the transaction is successfully completed. This is the address. You can click here, and you can verify the transaction that you have received 1 ETH. So I have switched my network, so I'll come back here, and I can go back to the network. So this is the network I have added. So select here, and you can see it went up to 6. So we have received our fund successfully, and that's how you can get it. So once you have the fund, now you can simply close all of this open tab and come back to remix ID. So I already have my remix ID, and make sure you have to use this particular remix ID, .ethereum.org. Don't use any other remix ID, because right now there is hundreds of fraud remix IDs there, and it's going to take your real fund out of your wallet. So don't use any remix ID. Use the exact ID which is there, and this is the only remix IDs available. So make sure to use the exact one. Now you can come back to the contract, and there you will find I have multiple contracts. So what I will do, I'll create a new file. So what I will do, I'll simply select the contract, and I'm going to simply delete all. Let's delete all. Let's select all, and let me delete all of this, so I can show you in better way. So right now there is no contract. I want to delete my artifact as well, so everything can be regenerated from fresh. So you can see I have this. I can simply click on this delete and delete it. So there is no contract and there is no artifact. So what I will do, I'll simply close here, and let's create a new file. So what I can call it, I can simply come back to my token, and this is the name I can give to my file. So I come back here. First I'm going to deploy my token. So I click here and give the name and give .sol. Perfect. Then I have to simply come back here. I have to grab the entire contract, and that's what I have to simply paste here. Okay, so we got our contract. You can see our contract got compiled successfully. There is no issue in our contract. Everything is looking great. This blue tick means you have compiled successfully, and if you want to check your compiler version, you can simply come back here. Make sure to use the latest one. So if you come back here, you can see this is the latest version I'm using, and I'm set to auto compile. So the moment I will set, it will automatically compile my contract. Perfect. We got that. Now our contract is here. Come back to the files. What I will do, I'll also import the other contract. So I'll come back here and simply copy this portion This is the name I want to give. I can simply, let's select this contract folder, create a new file, dot sol. So I'll got this as well, close this one, and I can simply get the contract. So come back here, select all, and that's what I can paste. So I got both of my contract. You can see it's compiled successfully. There is no issue in our contract. If there is any issue, it's automatically going to throw an error and it's going to highlight here. So we have got our contract, both the contract. So what I will do first, I'm going to deploy my contract, this one, the token contract, with this much supply. So first thing, you can come back here, and here you have to do the changes. So we want to use the actual test network. We don't want to use the remix environment. So I'll select here, and here I have to select this injected provider MetaMask, and it's going to pull up MetaMask, and you can see it will connect with your MetaMask. It's showing the wallet and this much fund. So I can simply come back here, and I'm going to simply switch the network. I don't know why it's by default it's Polygon Mumbai, but I'll go with this one. And this much fund I have. You can see the fund is reflecting fine. So make sure you are actually in the same network where I am. Okay, first test in this network, all the feature. After that you can simply use any other network. There's no problem. As long as you have fund in the wallet address, you can use that. So I'm connected with the exact network, and I have this fund, and I have this contract. So I can click here. You will find there's multiple contract because you're using the library, but we have to deploy our own contracts. So select that, and everything is good. Now we are ready to make a call and deploy our contract. So simply click on this deploy, and it's going to make a call to our smart contract. You can see we are paying this much fee and estimated fee. That's all you will find. So click on this confirm, and the transaction is in the pending state. So click here, and you will see the transaction is in the pending. Our contract, our token is getting deployed. So just wait. And here the token is deployed successfully. You got the address. So simply click here. So simply copy the address, and that's what we have to simply paste here. So come back here in the constants, close this one, and we have to paste our token address. Perfect. So this is our token address. Now we can come back here. If you really want to verify your token, you can simply come back, click on this transaction, click on this view on Block Explorer. It will take you to the Block Explorer, and there you will find all the details about the token you have created. You can simply click here, and you can able to see all the details about your token. So this is the name and the supply you have given. There is currently one holder, which is going to be you. Your transaction has the time block. Everything is looking perfect. So we got our contract of token deployed successfully. Now we can simply come back here, and as soon as you will deploy the contract, you will come back to the file section, and in the artifact you will have the ABI of the contract. So you can see this is the ABI. You simply select the ABI, and that's what you can simply provide. Come back here, and that's what you can provide here, and that's what you can simply paste here. So this is the entire ABI of our contract. We got it successfully. Now close this one. So our token is done, and token ABI is done. If you want to access the ABI, you can simply come back here and type .ABI perfectly. So this too is done. Now we have to get this too. So I can simply come back here, click on this, and I'm using the same account, so I'll simply copy the address, and I'm going to simply paste here my address. We got the address. Now I have to deploy my ICO contract. So come back here. Let's close all of this. We're done with that. Close this file. Now you have to click on this ICO contract. So we have selected this. We have to do exactly the same thing. Come back here and make sure you are connected with the wallet and with the same account. I'm using the same account. It's always good to use the same account. And here you will find multiple things. So you can click here. You will find this 2-1 interface and the contract. So we want to deploy this one. Select this and click on this deploy, and it's going to do exactly the same thing. So we have to simply confirm the transaction. Confirm, and the transaction is in the pending state. Once the transaction will complete, you will find that the contract will deploy successfully. So just wait. The transaction is in the pending state, and once the transaction will complete, you will have all of these details. And here the transaction is got compiled and deployed successfully. You can click and you can verify on the Block Explorer that our contract is deployed. You can simply see all of these details looking pretty good successfully. You can simply click here and you can able to find all the details about our contract. That's perfect. So you can come back here. Now we have to get the address. So simply copy this. It's a address of our contract, ICO contract. Now we can simply come back here and we have to paste the contract address here. So we got the address. Now we have to get the ABI. So we have to do exactly the same thing. So we got it. Come back here and I can simply come to the artifact. Inside the artifact we have the ABI, so this is the one. Simply copy, and that's what I have to paste here. So come back here and paste the ABI. Perfect. So we got the ABI of our both the contract. Close this one, and we are done with all of this important detail. Now we have to simply get the ABI. So we'll come back here, we'll give this dot ABI. All of this important details we have got it. Now once you're done with that, now you have to do the important thing. So come back here. Now we have to set this particular token, or you can set any token. I'm just showing you with this token, but you can literally set any token in the ICO contract, or later you can simply change that as well. So what we have to do is we have to set this particular token in the ICO contract. So I'll simply copy this one, and I can simply come back here, and I can go back to this, in this, okay, come back to the file. I'm going to simply close this one, and I can come back in the compile here, and here we have and here you will find our contract interface. So I have in our ICO contract, we have all of this function. So if we want to interact with our ICO contract, we can literally do it from here, because this is the interface we have. If you check the interface of our ERC20 token we have created, and you will find all the function is available, which you can simply interact with that. So what I will do is I'm going to simply set the token which I want to sell in the ICO right from here. Okay, I want you to do exactly the same thing, because we're going to build the functionality in the front end where admin can also update it. So first let's update that, because this is very important. So first simply update the address. So we have this function for updating the address. So this is the transfer we have, update token. Open this one, and only you can call this function. So make sure to use the exact account which you are connected. Now we have to simply call this transaction, and it's going to make a call, and you will see we are calling the function. Click on this confirm, and the transaction is happening. So if you click on this, you will see the transaction is in the pending state. Once the transaction will complete, this token will be added successfully. Just wait, and it's happening, and the transaction is completed, and we have successfully added the token in our ICO contract. Once we're done with that, now you have to also update the price of the token, that what price you want to sell your token. So we can come back here and come back to Way Converter. Come here, and I want to set my token price to be something like this. So like I would go with like 0.00001. So this is the price at which I want to sell my token. This much Way is going to be this much. So simply copy this one amount, copy the Way amount, and that's what you have to provide, because this time we are using this remix ID, but in the front end we already have a function which is going to convert it. Okay, so let's provide that amount here, sell price, paste the way you want, and click on this transition, and simply click on this confirm, and the transaction is in the pending state. Just wait, everything is good. So once the transaction will complete, you will see that token address is updated, token price is updated. Now we can simply build the front end where we can simply attach all the function, and admin can also update all of this token details and the price right from the front end. We're going to provide that option as well. So just wait, it's happening, and the transaction is completed. So we have updated the price, and we have got all of these important details. I hope you guys have understood that how things are coming together. So we have built all of this function in the content. We got the ABI and the addresses. Here we have all of this function in our index file. Everything is looking good. We are done with the contract. We are done with this particular one. And if you want to import this particular token in your wallet, you can simply do that. You can simply copy the address, and you can come back to the MetaMask, and there you will have this token. Right now you can see this particular token is available. So I can click on this import token, and here you have to paste the address. Click on this next, click on import, and you will see the token is not reflecting here. Sometimes it takes time, and this generally happen with the new token, but we're going to build a function in our application which is going to add this token forcefully, and it's going to reflect here. It's not reflecting, but we're going to add that feature. Don't need to worry about it. So that's the only thing I want to cover in this part. We have written a lot of code, and in the next part we're going to simply complete our entire project, and we're going to write entire code right here in the front end, and we're going to build all of the logic. So let's move to the next video.